All right, for number 4, so make sure you write it in the standard form. Standard form means dy by dx by itself. So we're gonna write dy by dx plus, so divide all by cosine square x sine x. So cosine, try to do step by step here. Cosine square x sine x y equals 1 over cosine square x sine x. That means this one is your px, and we see the power 3, power 2, we can reduce to be just cosine x over sine x, okay? And then your f of x is 1 over cosine square x sine x. So we're gonna find the integrating factor. Okay, I call IF integrating factor. And the notation mu equals e to the integral of the px. When you start working on the problem, I recommend you to write all the formulas. Try not to skip too much until you do enough problems that you feel comfortable enough to skip any formula to plug the terms in. Okay, so e to the integral, this is cosine x over sine x with respect to x. I keep writing with respect to x just to remind me. Right now, I'm working on the independent variable x. Okay, so integral cosine x over sine x. Do you guys recall how to find the antiderivative of this one?
Yeah, so this will be, you can convert it to cotangent.
The cotangent. Yes, you can convert to cotangent, but we are going to find the antiderivative of cosine x over sine x. So do you recall how to find the antiderivative?
Could you not use U sub?
We can use u sub. Yes, that would be the way to find the antiderivative. This one. So if you use the u sub, what would that be? What would be the u?
Sine.
Okay, I'm gonna put a note here. U is sine x. Okay, and then du is cosine x dx. So that pretty much we have the e to the integral 1 over u du, right? So e to the natural log u or u. And what is u? U is sine x. So the mu is sine x. Okay? It looks intimidating to begin with, but when you just follow the routine, it will come out. It's not as bad as what you thought. So are we good with the integrating factor? Okay? Yes. All right, next one, we're gonna plug it into the formula to find the solution, which will give you the general solution. Okay, y equals 1 over mu multiplied by the quantity integral mu times fx dx, and then plus c. The mu is sine x integral mu, which is sine x, and our f of x, what we identify at the beginning, is 1 over cosine square x sine x. With respect to x, and then plus c. Okay? Don't multiply 1 over sine x in until you are done the antiderivative. So we see sine x reduce, and integral of 1 over cosine square x. What do you think? What are we gonna do? Anyone? So now we have integral 1 over cosine square x dx, and then plus c. What do you think? How do you find the antiderivative of 1 over cosine square x? Could you think of anything? Think about what would be the equivalent form of 1 over cosine squared.
So it's secant square x?
Yes. Let's try. Thank you, David. So integral secant square x dx. Does it sound familiar now? Does it sound like something that we can find the antiderivative out of it? Yeah. Okay. So think about what function that is derivative is secant squared.
Tangent of x.
Yep. Yep. That would be the tangent x. So we have 1 over psi x over here, still in the integral sign, the tangent x plus c. And then we just clean up. So the tangent x over psi x plus c over psi x. And the tangent x is psi x over cosine x and multiplied by 1 over psi x. So therefore, psi and psi reduce. Okay. So your solution would be y equals 1 over cosine x plus c over psi x. Or you can write the first term as secant x if you like, and the second term as the cosecant x. So either one, it doesn't matter. So we get the general solution. Okay. Yep. All right. So for this type of problem, if you are asked to identify the transient term, okay, we will look at the fraction version of it or the rational form of it. To identify the transient term, we take the limit 1 over cosine x as x approaches infinity. What do you think we're gonna get? Eventually, what happens to the cosine function? Think about the graph of the cosine. The graph of cosine is kind of the wave, right? The up and down, up and down, up and down. It doesn't approach to any specific number. It just keep going. It's periodic function. So one is fixed, but the bottom is not stable. Basically, it's up and down. So in this case, the limit of 1 over cosine x will never be 0. It depends on the cosine function. So in this case, we don't really have to look at the specific limit value. We just said it's not going to be 0 because the worst case could be like 1 divided by 0, which is approaching like infinity, right? Infinity. So our goal is to identify the transient term where the limit is 0. So the limit of this term is equal to 0, which is a similar way to the limit of the c over psi x. Psi is the constant term, so it acts the same way as 1. So therefore, this case, there are no transient term. That means when you plot the graph of the solution, it's going to be kind of oscillating in some form because it's a combination of the two trig function. Okay, so that's number 4. Do you have question on number 4? This one? Well, good. Okay. Yep. Same. All problems you have done the same routine. Number 1, I keep in the standard form, identify Px, Fx. Number 2, find the integrating factor. And number 3, plug in the formula to find the general solution. Okay, and make sure you get the right mu, the right integrating factor. If you get the wrong one to begin with, you are wasting your time